In this lecture, we're going to use the connections QML component to capture a C++ signal and connect it to a QML slot. There are many uses for the connections QML component, and one of them is connecting to targets not defined in QML, and that's the case we are interested in this lecture. What we want to do is to define a C++ class, and the class is going to emit some signals. One of the signals is going to be called call QML, and the other is going to be called CPP timer. We want to connect to those signals. And the syntax you see here is no different from what we saw in the last lecture. We are using a connections QML element here. We are specifying the target, which is our CPP class that we are exposing using context properties. The signal we have in C++ can be captured in QML using this syntax here. We say on, capitalize the first name of the signal, and specify the rest of the name of the signal. You're going to see how this works in a demo that we are about to do. But the main idea is to capture the signal we send in C++ and use it in a QML slot, just like we are doing here. Let's head to Qt Creator and show you this in action. Here we are in Qt Creator. We're going to create our project as usual. It's going to be a Qt Quick application. We're going to call it Connections CPP Demo. We save it in the usual location, hit Next, choose your Qt version, choose your kit, and finish. We want to create our CPP class. We're going to call it CPP Signal Sender. We create it like this. Give it a name. It's going to inherit QObject. We go to the header file and we define our signal. Our signal is going to say call QML. It's going to take a parameter that is a string, and let's just call it parameter. Why not? We also want to specify a slot. We're going to use this slot to emit the signal to be captured in QML. So what we're going to do, we're going to put a button in QML. We are going to call this slot. When you click on the button, this slot is going to emit the signal, and we are going to capture the signal in QML. I know this is convoluted, but it is the easiest way I thought of showing you this in action. Bear with me, I'm going to explain it, and you are going to understand. Let's implement this slot. Right-click, refactor, add definition in CPP file. And here we are going to emit, call QML, the signal we just defined, and we are going to pass in a parameter that is a string. Let's just say information from C++. This is going to do. Now we have our class defined. We have our slot, we have our signal. We need to go to main QML and expose it as a context property. You already know how to do this. We're going to include QML context. And down here, we're going to include the class CPP signal sender. We're going to create an instance of that class. Let's call it sender. Why not? Down here, we're going to say engine root context, set context property. We're going to give it a name here, CPP signal sender, and we pass a reference to our sender here. Just like this class is going to be available for use in QML, and we're going to use this name here to access it. We can go to QML, change the title here. We're going to say connections. I want to include Qt Quick controls. Put a column down here. The column is going to contain a button and a text component down below. Let's call this text, and the text is going to say default. By default, the button is going to say, and when it is clicked, we're going to say CPP signal sender CPP slot. Okay, we are going to call the slot here that is going to emit this signal, and we want to capture this signal in QML using the connections component. Let's go back to QML. We're going to go to the top here, put in our connections component. The target is going to be our C++ class, which is called CPP signal sender. The signal we want to capture is on call QML. Let's go back to the class and confirm this on call QML. Yes, it is. We're going to respond in here. We're going to put a console log message saying that we caught the signal in QML. And we're going to capture the parameter that was sent by this signal and use it to set the text of this component here. That way we know that we indeed captured the parameter that came from the signal. So we're going to say mtext text equals parameter, because that's the name of the parameter that the signal is sending here. Notice that this name is very important. Let's spell it correct. Parameter. Let's go back to the, okay, here there's no problem, and here we say parameter. Notice that the name of the parameter is very important here. If you mess it up, your parameter is not going to be passed over. We capture it using the explicit name that we set here. So you have to remember this. Okay, before we run the application, I want to go through the flow of how this is going to work. We're going to click on this button here. After we click it, we're going to call a C++ slot. It is going to be called here. In this slot, we are going to emit a signal that is going to be captured in QML back again. Okay, we have a connections component. We are saying that the signal we want to capture is going to come from the CPP signal sender, the class that we exposed in main using the context property mechanism. We capture the signal like this, and inside the signal handler, we put a console message saying what we have, and we use the parameter text to set the text of this text component here. It really is this easy. Let's run the application. We have our app here. We have the button. It is saying call C++ method, and the text of the text element is saying default, which is what we expect. When we click on this, you see that the text is saying information from C++, and look at the messages that we have here. We're saying this is QML, call QML signal count, and we know that we are coming here after we emit the signal in C++. I really hope this makes sense. The main things for you to understand here is that you can send a signal from C++ and capture it using the connections element and targeting the class that you exposed in your main function, just like this. Okay, I know this might be convoluted for some of you. That's why I am going to go back to the C++ side and emit a signal completely from C++ without QML intervening in the middle. The way I'm going to do that, I am going to create a timer object. It's going to be QTimer class. Bear with me, you're going to see what I am trying to achieve right now. I am going to create a private section, create a timer instance, and I'm going to create an integer, call it value, like this. And I am going to define another signal that I am going to emit. It is going to be called CPP timer, and it is going to pass a parameter that is a string, let's say value. I am going to fall over to the CPP file. I should initialize my timer. Give it a parent, and my value is going to start at 0. This is going to be fine. Now I want to connect to when this timer times out, and every time the timer times out, I am going to emit my signal. Bear with me, you're going to see this after I type this out. I am going to say connect. I am going to use the lambda function signal connection notation. It's going to be mtimer here, pound symbol, qtimer, timeout. And it's going to be a lambda function that is going to capture everything in the context. We pass in the parameter list and a pair of curly brackets like this. Put a semicolon here. In the body of the lambda function, we want to increase m value, increment it a little bit, and emit our signal. We're going to say emit cpp timer, and we're going to say qstring number and say m value. Okay, we are emitting the value in our timer like this. And we should start the timer. And we want to emit the signal every 1 second. Let's try this. Okay, what I am doing here, I am emitting this signal every 1 second. Okay, this is the use of the timer. It is a class that allows you to do things periodically. This time our period is going to be 1 second. And you connect to the timeout signal of it, and you emit the signal every time the timer times out. I hope this makes sense. Now that we have this feature built in here, we are fully capable of capturing this signal in QML. To make this obvious, I am going to put in a rectangle here. I am going to give it a width of 200, why not? A height of 200. It's going to have a color of red. Let's give it a radius of 20. Inside, we want to put a text component. The ID is going to be mrect text. The text is going to be 0 by default. It is going to be centered in the parent. The color of the text is going to be white. And we want to increase the font a little bit. So we're going to say font point size. Let's make it 30. Okay. We can run this actually and see how this looks. Okay. You see our big rectangle here. So what we want to do is to capture the signal that we send, the CPP timer signal with the parameter that is changing every second. Remember, we are emitting this signal every second, and we are increasing the value every time we fall inside this lambda function here. So we want to capture the value every time it changes and update that in the rectangle component that we just defined in here. And that way, our signal is going to be completely coming from C++. The only thing QML is going to do is to capture the signal, grab the data, and use the data to set the text inside this text component here. So let's get to work. We're going to capture the signal. We're going to say on CPP timer. And we're going to say mrect text equals value. Remember that the parameter is called value here. Let's run the application, and hopefully it is going to work. Okay, you see that our timer is counting, and the signal to trigger the change of the timer here is completely coming from C++. And I hope this makes it very clear that you can use the connections component to connect the signals coming from C++ to slots in QML and do some crazy things like having a timer running like this. This is all I had for this lecture. In the next one, we're going to see how you can use Q properties to have automatic updates in QML when things change in C++. I'll see you in the next lecture.